Hi everyone. So today I'm going to talk about gate 2012 analog question. Okay, this question was asked in gate 2012 paper. Okay, in electronics and communication branch, and that year the topper marks was around 67 marks out of 100. So you can see this question was not that difficult, but yes, if you are going to follow the conventional approach, so it might consume a lot of time. Okay, so let's read the question. You have to see this video till the end so that you will understand uh, you know the hidden concept behind this question, right? So we have to solve this question within less amount of time. Okay, we don't have to follow that very conventional approach, okay, which you follow always. This question was asked in gate 2012 in ECE paper, right? And that year, the topper marks was 67. Okay, one of my close senior, right? He got 67 marks, okay, out of 100. And that year the paper was set by, that year the paper was conducted by IIT Delhi. So you can see this question, and this question is beautifully framed, right? You can see the option as well. So what they are asking here is that the voltage gain AV of the circuit shown below. The voltage gain AV of the circuit shown below is. So this is a question given. One single transistor is given, right? And they have also connected this 100 ohm from base to collector, right? It means that they have given the feedback also, right? So, and options are beautifully framed here. You can see the mod of AV, that is the magnitude of the voltage gain is approximately. You have to be very careful about these signs. Approximately 200, approximately 100, approximately 20, approximately 10, right? So this question can be done within 3 second to 4 second, right? So I'm going to give you the kind of approach, okay, which will help you to get the answer very closely, right? I mean, within 3 to 4 second. So this question was basically asked earlier as well in 2006, okay, in the gate paper only. If you will go back and check the paper, you will find this kind of a question, right? Okay. So let's read the question and let's see what is given here, right? So what they are asking is they are asking the voltage gain AV, right? Uh, we have to calculate the magnitude, but yes, the voltage gain for this transistor is going to be what? V out upon Vi, right? This is the small signal voltage gain, what they are asking, okay? Right. They are asking basically the magnitude, so we don't have to worry about the this negative sign. As far as this transistor is concerned, what is this? You have applied voltage at the base terminal, and you are taking the output at what? At the at the collector terminal. So it is common emitter amplifier, and the basic amplifier is common emitter amplifier, right? Okay. And they have also connected this base and collector here. So this is kind of a feedback. So we can just recall some of the basic thing regarding feedback. Okay. So this is the basic amplifier, that is A. Okay. Basic amplifier is A, that is common emitter amplifier, and there is a beta network, or you can say that that is the feedback network beta. Okay. Beta of the, it is not the beta of the transistor, it is the beta of the network. Okay, you can say the feedback network. And suppose here they have given the input Vi and this is the output. Okay, so basically in this kind of question, they have given the negative feedback. Okay, you can see here this is the negative feedback only. Okay, you can see, first of all, identify what kind of feedback they have given here is, right? So as far as this feedback is concerned, the 100 kilo ohm, okay, is connected between base and collector. So you can see this is shunt, okay, and this is shunt. So they have given shunt feedback. They have given shunt feedback. They have given shunt feedback. What does it mean? Okay, shunt feedback, right? Shunt means what? Input resistance will be low, okay, and output resistance will be also low. Okay, you can also directly tell about the resistance, input resistance of the amplifier and output resistance of the amplifier, right? If the output resistance of the amplifier is low, it means that what you are doing in the output, you are taking voltage, okay? So voltage shunt feedback it is, right? Voltage shunt feedback you can say, okay? Right. So if I try to find the transfer function from this, so V naught upon Vi will be equal to, there is a negative feedback, okay? So the basic advantage of negative feedback, if you know, then you can directly find the answer for this question. So the overall gain is going to be A upon 1 plus A beta, okay? This is the overall gain. This A is basically the basic amplifier, okay? Basic amplifier. And this is the feedback network, right? So as far as the advantage of negative feedback is concerned, advantage of negative feedback, what is the advantage of negative feedback? The advantage of negative feedback is basically, you have to keep in mind always, right? Advantage of negative feedback is what? It desensitizes the forward path gain. What? It desensitizes the forward path gain. Forward path gain. What does it mean? If there is a negative feedback, always keep in mind that your loop gain should be far greater than 1. Okay. If the loop gain is far greater than 1, so what you can do over there is V naught upon Vi will be can be written as A upon A beta, okay, because you would be able to eliminate one, okay, you can neglect one over there, so this will be the overall gain. So here you can cancel A and A, so approximately your overall gain would be depending upon beta only, okay. So what is beta? What is made up of? What beta is made up of? You know that the beta is made up of only resistances around the transistor, right? So you can see here there are resistances connected around the transistor. So your overall gain is now depending upon what the resistances only, okay. As far as the op amp is concerned, you might have seen op amp, okay. So you have to keep in mind that advantage of negative feedback. What is the advantage of negative feedback? It desensitizes the forward path gain, means you don't have to consider now the basic amplifier, okay, while determining the overall gain. What you have to focus here is you have to focus on the resistances connected around it. So you can see if I consider any op amp circuit here, suppose this is kind of a op amp, right, and this is grounded, and just I'm considering inverting op amp, right. So you can see here this is V out, and this is input Vi, right, and this is R2, you can say this is R1. So what can be the overall gain of this kind of amplifier? This is op amp, and we are considering that the op amp is ideal and it has huge gain, okay, 10 raised to power 6, 1 million gain, you can say, right. So the overall gain will be equal to what? Overall gain basically will be depending upon what? Overall gain will be depending upon the resistances connected around it. So that is going to be minus R2 by R1, right? This is going to be the gain for inverting amplifier, we know, okay. We can find directly by applying some virtual ground concept. So 0 volt will be here, and then you can just apply node, or you can directly write, okay, because the current will be flowing here is Vi by R1, okay, and this current will flow through this R2. So here you can calculate the V naught, and V naught by Vi will be minus R2 by R1, okay. So the way we calculate gain for the op amp, ideal op amp, right, in the same manner we can also determine the what gain for this transistor, okay, this transistor. So overall gain will be what for this transistor? I'm just talking about the magnitude. So here you can take this 100, okay, 100 kilo ohm will be R2 upon this 10k. So you can just, okay, so it will be approximately 10, okay. You can see here I have considered BJT Okay, I have made assumption that the basic amplifier doesn't play any role here. Okay, why? Because there is a negative feedback. If there is a negative feedback, the basic advantage, the wonderful advantage of negative feedback is what? It always desensitizes the forward path gain. Okay, if the gain is very high, so you can neglect one, you can neglect one here, you can neglect this guy, right? Here what we are considering, a beta is far greater than 1. This is the loop gain. Okay, so this is going to be overall gain. Overall gain is now depending upon this beta, and this beta is what? The feedback factor of the feedback network, right? Feedback factor you can say. And now as far as the calculation was for op amp, we have done, that is v naught by vi is r2 minus r2 by r1. The same manner for BJT also. So you can see that this, if you have to travel from here to here to here to here to determine entire gain. Okay, overall gain. You don't have to worry about now this transistor. If suppose this transistor is of a MOSFET transistor or metal oxide semiconductor field effect transistor, so you don't have to worry about the basic amplifier, right? Be it suppose there is a common source amplifier connected, still you can directly tell that that answer is going to be 10. Okay, so the option will be 10. You don't have to worry about, I mean, you don't have to go for the small signal analysis. Okay, small signal model. Here you waste your time, here you waste always your time. I have seen many solutions on YouTube channel from where you always consume passively the content. So that method is wrong. I mean, that method is correct, but if the method is consuming hell lot of time, it means that that method is wrong for the gate examination, remember. So first of all, if the feedback is given, okay, if negative feedback is given, remember, negative feedback is given, then your overall gain is going to be what? Your overall gain will be depending upon 1 by beta, and beta you can calculate from the feedback network. Okay, because beta is basically here the feedback gain or feedback factor, you can say feedback factor. I hope this solution you might have liked. Okay, so this kind of a solution you will not find anywhere. Okay, and this is one of the very good solution. Okay, and easy to get any kind of answer. Okay, so you can also check 2006 paper, and there was also one question, okay, asked in the gate examination. So there also you have to find the overall gain. So that answer here is 10. Okay, so in my case, if I am going to if I would have attempted this paper, so I would have solved this question within 3 seconds. I hope you like this session. So what you have to do here is you have to share this session among everyone, so that everyone could understand that how to solve questions in real manner. Okay, you don't have to follow a big approach and waste a lot of time on analog circuit, because analog circuit is one of the very beautiful subject where you have to use the advantages of the negative feedback. The major advantage of negative feedback is what? Desensitization of forward path gain. I hope you like this session. Thank you so much. We'll catch up in the next session with new question. Thank you. Ravi Teja is asking here in BJT how to identify negative feedback. Yeah, it is one of the very good question, right? So as you can see here, yes, very good question, right? So as far as this amplifier is concerned, right? So you can see here, this input is connected, okay, to base, and you are taking output at collector, right? And there is a feedback involved. So always what we do here is always we study amplifier with respect to negative feedback only, right? We don't study amplifier, okay, with respect to the positive feedback. Otherwise, in case of positive feedback, what will happen over there is you can't get amplification, right? So always whenever question will be asked to you, okay, Ravi Teja, So there would be always, I mean, you have to consider there is a negative feedback only. Okay, there is a negative feedback only, right? So this is one of the very yes, understand. I hope you have understood this, and you don't have to worry about much. Okay. Uh, yes. In case of amplifier, if you want amplification, so there should be negative feedback always. Negative feedback. And if there is a feedback involved, there is a feedback involved in the amplifier, then you can get any answer, any kind of questions you can solve within less amount of time. Okay, so we will come up with more questions, okay, and we are going to solve questions in this manner only. So please hit the like button and share among everyone so that everyone could understand this is the real way of solving question. Otherwise, many people fail and they experience phobia of solving questions from analog circuit, right? I have experience across the country I have been, so I used to see, and in fact everywhere the solution is given by using some conventional approach. So this is one kind of a solution, and needless to go for conventional approach to verify, because nowadays in the gate examination what happens, they ask questions and you have to answer the questions using some approximation method as well. It's okay, so we'll catch up in the next session. Thank you.